Hey going guys, Curtis from Cutting Edge Engineering. So today's job we're going to get started on building a tool post grinder to go on our lathe. Because we've gone ahead with purchasing the metal arc sprayer, we need to start getting things set up, and a tool post grinder is at the top of the priority list. So we could definitely buy a tool post grinder. A cheap one is about $1,000, but you get what you pay for. The more expensive ones can be upwards of $6,000 to $8,000, but they are hard to come across here in Australia, and by the time you pay freight to get them in from overseas, they're just way too expensive. So we're just going to build our own. We've already done 3D drawings on what we want to build, and it's going to have a few features that the ones you buy don't. We will have a 3-phase motor on there that you will be able to control the speed using a VFD. We're also going to make it with a changeable spindle for external and internal grinding, and our internal spindles will be able to reach much further than anything we can buy on the market. So what we're going to get started on is building the mount that goes on the top slide. We've already got all the plates cut from our local plate supplier to the correct profile. All we need to do is clean them up and we can start machining. So all of our plates have been cut from 350 grade plate. Our main base plate is 100mm thick. We then have some 20mm plates, and the two triangles are 10mm. Before we can start measuring and marking things out, I do need to take the tool posts off the top slide. So typically there are two ways to mount a tool post grinder onto a lathe. You can remove the tool post and mount it directly on the top slide, or it can be mounted into a holder on a quick change tool post. But because of the size and the weight of our grinder, we're going to be mounting it directly on the top slide to get maximum rigidity and accuracy. So now we've got those measurements and those clearances, we're going to mark out the base plate. Now we've got it marked, we can get it set up in the lathe so I can drill the hole and machine all the clearances. The hole is going to be 39 mil, and that will give us 1 mil clearance around our 38 mil mounting post. So I'm going to drill a 38 mil hole and then bore it to size. So now with the hole done, I'm going to shorten up the boring bar so we can start machining these other details. The first detail I'm going to machine is a 52mm diameter, 41mm deep from this base. The next detail I'm going to machine is 116.8mm in diameter. I'm going to rough that out and then we'll take some measurements. So I've got that roughed out, I've taken our measurements, we've got 2.8 mil to remove, so we'll do our final cut and clean up that back face at the same time. So the final detail will be for the very base of the mount, and it'll be 126.2 mil in diameter, 6.2 mil deep. So that's all the details machined. As you can see, we are cutting it a little bit fine on these two outer edges. Ideally, I would have liked about another 10 mil of material there. That would have brought it out level with the top spline and made everything look nice and clean and in alignment. Unfortunately, something got lost in translation between Troy and myself, and this is what we ended up with. So now all I need to do is chamfer these sharp edges and then face it, and that's all the lathe work done for this part. So before I get on to machining any other parts, I do want to make sure this fits. So I need to take the tool post off again, test it on there. Hopefully everything fits exactly the way it's supposed to. Otherwise it's going to be a bit of a pain to dial it back in. So that's a really nice, neat fit. There is no excess movement. Looks exactly the way it should, except for that little bit of missing material. But I'm really happy with how it's turning out so far. So now what we need to do is get some parts set up in the mill. So these parts are going to be the clamps for the spindles, so we can remove them and go from internal to external. So all I need to do is machine the clamping faces and drill and tap 4 holes. So with those parts done, now we can set up the top parts of the clamp, and with these all we need to do is face them and drill them. Now with those done, the last thing we need to do is mill a bevel on this plate for a weld prep. Now with that done, we can start the assembly process. We've got a few parts we need to weld together. So I'm just going to tack together the plates for the clamps, and then we can fit and tack that onto the main plate. So it is very important that I get these clamp mounts as close to center height as possible. So what I'm going to do is use the quill of the tailstock to sit that in position. Then I can take some measurements and get it within a mil or so, and then we'll tack it in place. But I still do have a couple of mil of material that I need to remove from the ID of the clamps. So once it's welded together and everything's cooled down, we'll be able to reset it back up in the lathe and bore them so they are on perfect center height. So I'm just going to cover this in anti-spatter spray and then we can weld it out. To weld this out, I'm going to be using ER70S6 and backing that up with Argo Shield Universal. I'm going to be running that at about 27 volts and 9 meters of wire a minute.
Oh, Jeffrey. Hello. Go on, go out. Sit. You've already had some.
Now that that's cooled down, we can sand down some of those welds and make it look a little bit nicer. What I'm going to be using is a sanding pad, which is a 36 grit. So now we've got that done, we can set it back up in the lathe and we can bore the clamps to the correct size. Now that that's set up, for my next process, I need to change out from my 4-jaw chuck to my 3-jaw chuck. In order to bore out these clamps, we're going to be using the lathe for line boring. So the tool I'm going to be using is a 50mm boring head with my 300mm extension. And I'll be using an ECGT insert that we commonly use in line boring. And I'm just going to eyeball the center of the clamps to the boring head. So because we're making our own spindles for this, I'm just going to bore out those clamps until they clean up. So I've done a couple of cleanup cuts and we've got that measuring at 99.92. We are sort of aiming for a standard size number. 100 mil sounds pretty good. So I'm going to advance the tool 0.04 of a mil, which will give us our 0.08 to finish it up. So we've got that board to size. Getting it to 100 mil means it's going to be a lot easier when we go to manufacture the spindles. That's standard size material, which means we can run standard size bearings. But one thing we will have to do is machine 0.1 of a mil off the face of the clamps, and that will allow for tight clamping over the spindles to stop them from spinning. Righto guys, so that's the build for our mount on our tool post grinder completed. The next thing we need to do is make up the spindles, so keep your eye out for part 2. Thanks for watching. You ready? My head on straight?
Yeah.
You sure?
Yeah.
Right. So typically there are 2 ways to mount a tool post grinder. Oh fuck, what was after that? To get maximum rigidity. Oh, what was after that?
Accuracy.
Right. Oh wait, what was after that? Oh fuck, what was after that? Oh wait, how'd you start that? The first detail I'm going to machine is a 52 mil. Oh, what did you say, diameter? Right. The first detail I'm going to machine is a 52. Oh fuck me. You right? That way you can control the speed to achieve a certain finish. And if it didn't take a week to get a new piece of plate, clut. So that's a nice nice fit. So that's a nice nice fit.
Jesus
I
Christ.
can't say words. So the last thing I need to do is chamfer all these.
I think the 2 sets of glasses help the situation.
Those ones are definitely clearer. Very good. Yeah, nah.
Not it. Let's see how long it takes to find it. Doesn't look right. Okay, you can't help it.
No, you gotta look around and make sure I was watching you.
Stop, just keep going, keep going. Inheritance machining's like, yuck! It's kind of just smouldering. It's doing the smolder. Go get it. Why are you going that way, homeless? Homeless, what are you doing?